All right, so today we're going to talk about molarity. And so the molarity equation helps us to create solutions of specific concentrations when starting with a solid compound. So molarity is just a concentration, the amount of solute that is in an amount of volume. Now there's lots of different ways that we can calculate concentration, but for molarity specifically, it is the moles of solute in the liters of solution. So it's the amount of particles that are stuck in that liquid. And like I said, that is equal to molarity, which we signify with a capital M. And so this molarity equation is when we're starting with a solid compound. So we use this when doing labs all the time. Whenever someone makes a solution, you need to use this equation to create a solution with the correct concentration or molarity with the amount of volume that you're looking for. So for this first example, I'm going to walk you through how we would do it in a lab. So here it says create 0.5 liters of a 1.5 molar solution of magnesium chloride. So when we're looking at this equation, we have molarity is equal to moles over liters. Well, molarity is what we're looking for, and we know that we can measure liters using any volumetric sort of flask. So we can use a beaker, graduated cylinder. Those things will help us measure volume. But moles is not something that we can measure, right? Moles is, you can't put it on a balance and figure out moles. So moles is not super practical, but we can convert moles to mass because mass we can measure on a balance. So our first step here is going to be to figure out how many moles we need to create this concentration in this volume, and then convert moles to grams so that we can put the correct amount of solute into this solution. So that's what I'm going to do first. Solve for moles. So my molarity equation is molarity is equal to moles over liters. So it told me that I had a 1.5 molar solution, so that goes in for molarity, is equal to X over, now it told me my liters was 0.5 liters. Make sure that your volume is always in liters. If it were in milliliters, you would have to convert to liters. Okay, so now we have to solve for X. So I'm going to cross multiply here, multiply both sides by 0.5 so that I can get X is equal to 0.75 moles. Now it told me that it was MgCl2, so I know that I need 0.75 moles of MgCl2 in order to create this solution. So my second step is going to be to solve for grams. So I use my railroad tracks, my conversions, to go from moles to grams. So I go to the periodic table, I'm going to add up the molar mass of 1 magnesium and 2 chlorides. So I get a molar mass of 95.21. When I multiply across, I get 71.4 grams. So that's going to tell me that in order to create this solution that has a concentration of 1.5 molar and a volume of 0.5 liters, I need 71.4 grams of MgCl2. So now if I were doing this in person, I solved for moles and then I got my grams. Then to actually make this solution, I would measure out 71.4 grams of MgCl2. Then I would put solid into volumetric flask. Fill rest of flask with water for desired volume. And mix. And that's right there how you create a solution. So this is if we're doing it in a lab. This next question is just math solving problem using our molarity equation. So here it says, what concentration of a solution would be created if putting 7.9 grams of NaCl into a 0.750 liters of water? Okay, so concentration is going to be our molarity. So remember, we have our molarity is equal to moles over liters. And so we know that we're solving for molarity. And we know that we have our volume, so that's our liters. But then they gave us grams. Grams doesn't fit into the molarity equation because remember, it was molarity is equal to moles over liters. So what we're going to have to do is take our grams and convert it into moles so that can fit nicely into this equation. So 7.9 grams of NaCl get out of grams and into moles. So 1 mole is equal to the molar mass of NaCl. So 22.99 plus 35.45 is 58.44. So 7.9 divided by that, 0.14 moles of NaCl. Okay, so now I'm going to put that answer in the mole section. All right, so 0.14 divided by 0.75 would give me a concentration of 0.19, and my units are big M. So this is how you would solve a molarity problem.